Good morning, grade 7s.
Good morning, sir.
Okay, the topic I will be focusing on is electric circuits.
Yes, sir. I love it.
So the electric circuits are composed of different components, and those components are the ones that makes up an electric circuit, and I will be naming them. So first, in an electric circuit, you have the battery or a cell. So a battery, it's what we say it's a power source. It provides electrical energy to the electric circuit. And then secondly, we have the conducting or connecting wires. I prefer to use the word conducting wires. So these are the wires that transport electricity around. They carry electricity. They transport electricity around the circuit. Electricity, or we refer to it as electrical energy. So the common wire that is used here is copper, whereas there are more than there are other metals that can conduct electricity, but in terms of electricity, the most common one is copper. And then moving from there, we have a device. So there are different types of devices and the device, the function of it converts electrical energy into a desired form of energy, So naming the devices, the most common one we have the bulb. So a bulb, it converts electrical energy into light energy. And then secondly, we have a buzzer or a bell. A buzzer and a bell, both of these, they convert electrical energy into sound energy. So they convert it into sound energy. Okay, and thirdly, we have a motor. A motor converts electrical energy into movement energy. Okay, and then in grade 7, I will be introducing you to a new device that we didn't do in previous grades, and that is an electromagnet. Electromagnet. So the electromagnet converts electrical energy into the magnetic force. So when the electromagnet is connected to an electric circuit, it converts electrical energy into magnetic force, meaning that it will act as a magnet, be able to attract all the magnetic metals. Are we clear? Okay. Moving from here, we are going to be focusing on the symbols. So before we proceed, we need to know the symbols that we use in electric circuits, and I'll be showing you the symbols for all these devices. For the bulb, for the buzzer, for the motor, for electromagnet. But for the buzzer, I will only just do one, either a buzzer or a bell. So I will be drawing the symbols for each first. So we start with the bulb. So for a bulb, we use a symbol like this. So this indicates a bulb. And then secondly, for a buzzer, the symbol is like this. Okay, here I will not be drawing all two of them. This is a buzzer symbol, and then that is the symbol. And then thirdly, for a motor, we use a symbol that is similar to that of a bulb, but instead of X in between, we have M indicating the motor. And lastly, we are going to be introduced to an electromagnet. So an electromagnet has got a symbol like this, and this is an electromagnet. Okay, with the things that I've shown the symbols for all devices, and then now I need to show you the symbols for a battery, a cell, and then a battery. So a battery is composed of many cells which are connected together. So I'll start with a symbol for a cell. So a symbol for a cell, it's like this. This is the positive terminal, and this is the negative terminal. Then it will be shown like this in your electric circuit. And then when we say it's a battery, then it is composed of two or more cells connected together. So let me start with two cells. Okay, that is a battery. Or it can have 1, 2, 3, or even more. It still follows the same thing. This is the negative terminal and this is the positive terminal. And then now, because there are two or more cells, we say it's a battery. Okay, and then we move on to the next next component. The next component is conducting wires. Conducting wires. These, they carry electrical energy around the circuit, and then they are indicated with the symbols of straight lines. So you need to use a ruler for this. They are made up of straight lines, and these are the conducting wires. Okay, in addition, because a circuit needs to function and it needs to stop at certain points, there is something that gets to be added, which is called a switch. So a switch functions to control the flow of electricity around the circuit. It controls the flow of electricity around the circuit. It controls the flow of electrical energy. So it is the one that stops and starts the flow of electrical energy around the circuit. And the switch is simply indicated with a symbol like this. So this symbol will indicate a switch. And if it's like this, we say it's an open switch. So when it's open, there will be no flow of electricity. That means the electricity will not move around because it's open. And then we have a second situation where we say it's a closed switch. So when it's closed, the wires are fully connected and they complete the circuit, which they create a closed. In this case, we say it's a closed switch, which they create a complete loop that allows the flow of electricity. And the next one will be drawing electric circuits. So when we draw electric circuits, one, for conducting wires, we use a ruler. They must be straight, and then they must complete a loop. And then electric circuits, they take the form of a rectangular shape. So all the components are going to be fitted within that rectangular shape. Not using a ruler, but when you are drawing alone, you need to use a ruler and try to make sure that all your lines are straight. That adds to the neatness of them. So I will start, maybe before I start, let me bring back the symbols. This is a symbol for a cell. This is a symbol for a cell, negative, positive. And secondly, a bulb, that is going to be a symbol. And a buzzer, this is going to be a symbol. And then a motor, this is the symbol with M inside, not with X. And then this is the symbol for an electromagnet. So how do you draw a circuit? One of the things that you need to pick up is that all these components, they have these ends. So these ends indicate where they need to be fitted into the wire. So these ends that I'm circling here, they indicate where they need to be fitted into a wire. Okay, before I forget, let me also put a switch. Okay, open switch. This is what it indicates, that it must fit it into a wire in this. And then a closed switch. Also, this is where the wire must be fitted. So let me make an example. I want to draw a circuit with two cells. So the circuit must have two cells. It must have one bulb. It must have an electromagnet, one electromagnet. So that is what the requirements are, and that is the circuit that I need to draw. So I start with the cells. So that is the cell number 1, cell number 2, and then I will put the conducting wires. Okay, I forgot one thing, so it must also have a closed switch. So what I will do, and then I will place my switch there, and then that's a closed switch, and then I move, and then it must have a bulb, so a bulb goes in there, and then it must have an electromagnet. So let me put my electromagnet here. So that is a complete circuit. And you note that the wires that were going out of electromagnet, they connect exactly to the wires. So certain mistakes that I always pick up is that people will draw the wire like this. And then when they get here, they put an electromagnet like that. So that is not acceptable. And then they will also draw a wire like this. And then when it gets to the bulb, they put a bulb like that. That is also not acceptable. And then when they put a buzzer, you will find that they draw a wire like that, and then they put a buzzer like this. This is also not accepted. Things that are not accepted when you're drawing the circuits. You will find that the wire is going like this, and someone puts a battery like that. This is also not accepted. A battery goes into a wire like this. Okay, so it goes into a wire like this. And then we also further, I've noticed other things that people, they will draw a line like that and then they put a switch like this. So that is also not accepted. A switch is like this in a wire line. Are we clear?
Yes.
Open switch is also like this in a wire. So that will be an open switch. Okay, just to do more practice. So now I will be doing another electric circuit. In this electric circuit, the requirements are that it must have 2 cells. I will keep it on 2 cells. And then it must have 1 electromagnet. As well as it must have a buzzer. So the intention of such circuit will be that when it's functioning, when the buzzer is switched on, when the circuit is switched on, it's able to report by making a sound. So that sound will indicate that the electromagnet is switched on, because electromagnet we cannot see when it's switched on or off. We either add a bulb, which is the most common one. We add a bulb. Okay, in this case, I'm adding a buzzer, but that will be an unfavorable situation because you will be working with an electromagnet and you are listening to a buzzing noise, which is not good for anyone to work around, but I'm just doing it for demonstration. And it must well and have an open switch. So it must also have an open switch. So how do I start with that? So 2 cells, there are my cells, and then I add connecting wires, and then I need to add an electromagnet. So an electromagnet should be somewhere here, and then we continue, and then here I am going to add a buzzer, and then that is the buzzer, and then we move. Okay, on the other side I am going to add a switch, and from the question it is an open switch. So that is an open switch. Okay, start. Okay, so when you are drawing electric circuits, the other thing that I will ask you is to indicate the direction of the current. Indicate the direction of the current. So there are 2 situations. One, it's the direction of the current. The direction of the current is the flow of the charges. So when we talk about the direction of the current, we are talking about the flow of the charges. And which are those charges? The negative charge and the positive charge. And this we refer to them as the negative charge. They are also called electrons.
Yes, sir.
And the positive charge, it's called protons. So in reality, the electricity flows from, the charges, they flow from negative to positive. So that means the charges that are moving, it's negative charges, which are electrons. So sometimes they will describe the current as the flow of electrons. So in simple terms, we say the current is the flow of electricity, but sometimes you'll say it's a flow of electrons. So what do you do when I say indicate the direction of the current? Go to your battery and then you put an arrow which indicates the flow from negative to the positive side, which sometimes other people will go on to add more than just 1 arrow until they reach the other side. But that is not really necessary. You can just add 1 arrow as long as it points to the right side. So this is what we say it's a flow of current. And when we speak about conventional current, This is an ideal situation. It means it's not a situation that exists. It takes the assumption that the current flows from positive to negative. And I will not ask anything about conventional current, but when you are asked about conventional current, you must know that it's a flow from negative to positive. But when I say indicate the direction of the current, it's a flow of current from negative charge to the positive charge. When you talk about a diagram, we are talking about a drawing or any other form of visual which shows a certain thing. And when you talk about system, what is a system? Anyone who can tell me what a system is? Yes? Okay, so a system refers to two or more parts working together to do something. So for a system to function, it requires certain things. One, it needs an input. So there needs to be an input. And then who can tell me what an input is? Anyone who can tell me what an input is? Yes? It's something that helps the system work. In this case, normally we refer to this as energy. So we are going to say the input energy that goes into the system to make it work. So the input is the energy that goes into the system to make it work. And then secondly, in a system, we are going to have a process. So who can tell me what a process is in the system? Anyone who has an idea what a process is? Yes? It's how the input is changed to the output. How the input is changed to the output. It's how the input is changed to the output energy, that is the process. And then lastly, we already specifying here the output. So there is going to be an output. And what is an output? Yes? Can you please repeat? The end results, the energy that comes out of the system. And normally this is a desirable energy that comes out of the system. So normally this is the desirable energy. That means is the energy that we require. So let me make an example of a system. Who can give me an example of anything that we say is a system? Actually. Yes? A bicycle. So we are going to talk about a bicycle. That is the system that we'll talk about. So a bicycle is a system. It's composed of two or more parts which are joined together and they work together. So what is that input energy in a bicycle? Who can describe for me the input in a bicycle? Yes? Yes, but describe how do we put that input? Okay, so in a bicycle, someone sits on it and then they pedal.
Yes, sir.
And then what is the process? Yes. The pedals makes the wheels move. And then what is the output? The bicycle move forward. So when we draw a system diagram, we are going to say the input, and then under the input we describe what happens with pedal, and then the type of the energy there, it's the movement. We pedal and the type of energy is the movement, and then the process. We say the pedals move and they also cause the wheels to move. And cause the wheels to rotate, and then after that we get the output, and the output is the bicycle moving forward. And that is the movement energy. So the input and the output are types of energy we also describe, and then that's what we refer to as the system diagram. So this is the system diagram of a bicycle, and there are different systems that we can talk of. We have mechanical systems. And we have electrical systems.
Sorry for the interruption. May my chief come to the reception? May my chief please come to the reception immediately? Thank you.
Electrical systems, they require electricity in order to work. That means all their inputs is going to be based on electricity, either from a battery or the mains electricity. And then mechanical systems, they require force in order to function. So those ones, they are using a force in order to function. So it can be a movement from our bodies, or it can be a movement from a certain thing, but there must be an input of a force in order to function. So we are going to close this one here. Thank you.